This is Bob Capetta, Professor of Mathematics at College of DuPage. Mathematics for Health Sciences, and today's lesson is Correlation Part 2. We're going to be examining data from the Vanderbilt medical datasets, and we are going to again examine the diabetes data. In particular, we're going to ask ourselves the question, what is the correlation between waist size and HDL level for men in that diabetes data set? HDL level is good cholesterol, so one might guess that as waist size increases, good cholesterol levels would decrease. Our data set has 166 records. We'll take a look at those to indeed see what that correlation is and what that means. So here is a subset of that data. And we're going to ask Excel to compute the correlation coefficient. Remember, the correlation coefficient is a number between -1 and +1. If a correlation is positive, as one variable increases, we expect the other to increase. If the correlation is negative, as one variable increases, we expect the other to decrease. Our command here is going to be equals correl, C-O-R-R-E-L. And then we're going to highlight the two bits of information we're interested in. Now I wanted to look at first at weight and HDL, waist size and HDL. So I'll highlight the column for waist size until that's finished. Put a comma at the end of that. And then we'll do the same thing for HDL level. Highlight the relevant numbers in the HDL column. And at the end of that, we'll put parentheses. And we should get our correlation. And we would expect that correlation to be negative because as waist size increases, we would expect HDL levels, good cholesterol levels, to decrease. Is that the case? Looking at our numbers, we can see we get a correlation coefficient of -0.389. So let's say that R, that's the letter we use for the correlation coefficient. So R equals about -0.389, about -0.4. Not a very strong correlation, but it is moderate. There is a slight relationship there. So we'd expect to see that somewhat in our scatter plot. So let's do that. Let's highlight the relevant data, the waist size and the HDL, and we'll ask Excel to give us a scatter plot. So we'll click on the scatter plot button. Mark scatter is good enough. And move that so you can see it. So indeed, there is a general downward trend. It looks sort of like a cloud, though. I mean, it's not a perfect straight line decrease. But in general, as the one variable goes up, the other variable tends to go down. Frankly, I would prefer, though, to have done that the other way. Well, no, on second thought, I think this way is fine. The waist size is the independent variable in this example. So as waist size increases, as a person's waist size changes, we would expect that their HDL level would decrease. So indeed, that fits the model that we would have expected. Now let's try that using the internet website that I looked at in the last video. So it's available at socsistatistics.com/tests/Pearson. And we want to go ahead and take a look at that. So we will indeed do that. Take me to the calculator. And we need to enter the data. So I'm going to go back to Excel. I'm going to copy my X values. I'm going to copy my Y values into that data set, and then we'll see what happens with it. We'll see how the computer analyzes it for us. So I've done that. I've collected the data from Excel. I've put it in. And now I am ready to go ahead and calculate R and see what sort of analysis this software gives me. So you'll notice the value of R, the correlation coefficient, is -0.3892. And they're giving us some discussions on this. You'll notice there's the same scatter plot that we saw on Excel. As the X value, which was waist size, goes up, the HDL level or the good cholesterol level tends to go down. Now there's a lot of analysis here as well that you can take a look at. But the bottom of the page, I think, is what's most interesting. And you'll notice it says this is technically a negative correlation, but it's a relatively weak one at -0.3892. but I would argue it's more than likely significant. Now, R squared is an important notion in statistics. That tells us the percentage of the variation in one variable that can be explained by the variation in the other. But a negative 0.3892 indeed as one increases, the other decreases, although we certainly wouldn't say that this is a strong relationship. Returning to the data set, a more direct correlation might be between weight and waist size. So let's ask ourselves that question. If we look at that, as a person's weight increases, you would expect a person's waist size would increase. In that case, we would want to have a positive correlation. Let's see what that positive correlation is, and let's see how strong that one is. So I'm going to highlight the column of weights, put in a comma, highlight the column of waist sizes, end it with the parentheses, and we'll see what sort of correlation we get. A positive 0.854 correlation. So this was the correlation of waist versus HDL, our first example. Waist size versus HDL. And this one is waist size versus weight. And we certainly wouldn't expect a fairly strong positive correlation with those two variables. Let's highlight weight and waist size. Let's take a look at the scatter plot for this data. We expect a positive correlation, a fairly strong positive correlation. So we'll hit the button for scatter plot, and you will see that indeed there is a relatively strong correlation. As weight increases, waist size increases in our data set. And let's go ahead and use the same data over in the internet application and see if the results are the same, and more importantly, see what kind of conclusion they give us. So you'll notice I entered the data of interest. Remember, the first data column is weight, and the second data column is waist size. And then we need to calculate R. And you'll see that the computer is giving us an R value of 0.8542. And there's our scatter plot, and again you'll notice a very strong linear relationship, the same scatter plot that we had in our Excel version. So with this strong linear relationship that has a positive slope, we expect the correlation coefficient to be fairly close to +1, and you'll notice they're giving us a correlation of 0.8542. So as we scroll to the bottom, we can see what sort of information they give us here. They're saying that the value of R is 0.8542, and they're saying this is a strong positive correlation. So as the X values increase, the Y values also increase. As weight increases, we would certainly expect waist size to increase. The R squared of 0.7297, so 73% of the change in a person's waist size is reflected by change in weight. But again, that seems reasonable in light of this. Other issues might be how tall a person is might have an effect, because obviously a person could be tall, be relatively heavy, but have a fairly small waist size. And that will conclude this lesson.